Okay, here we go. This is the video for 4.6, which is the fundamental theorem of algebra. Probably the most interesting thing you will ever learn in your entire life. Yeah, no, just kidding. Okay, anyway, so what the fundamental theorem of algebra basically tells you is how many zeros are found in a polynomial. We've talked a little bit about it before now, but now I'm actually telling you, hey, this is a theorem, and you can roll with it. So this equation right here, the lead degree is 5, so that means it has 5 zeros. Okay, so that means they could be real, non-real, positive, negative. They could have square roots. We don't really know, but we do know that there are 5 zeros. So if you remember from 4.5 when we found zeros, I told you that you had to do it algebraically, but you could still use the calculator. So what we're going to do is plug in the equation that we have, which is x to the 5th plus 3x to the 4th. Plus 9x cubed plus 23x squared minus 36, okay? And then we're going to go to our graph and see what it looks like, okay? So what we're seeing here is something to kind of make a note of, just so that you don't have to do this. I'm not going to give you points to do this, but it might help you if you do this. We see that there's a 0 right there and it bounces, okay? So we know that we're going to have one bounce or 1 0 that repeats, okay? And then we're going to have 1 that crosses, okay? So this bounce actually accounts for 2 of the zeros. The cross accounts for 1, so that's a total of 3 zeros, meaning that we are going to have, because we have 5 zeros total, we're going to have 2 imaginary zeros. And that's just something to know going into it, so you kind of know what to expect, okay? So what we're going to do first is we're going to find one of the zeros using our calculator, okay? I'm going to find this one right there. So I hit second calc, I go to 0. I find the left bound, which is right there, and then the right bound, which is there. And it's thinking really hard. The 0 that they found was at -2, okay? And because I know that it bounces, it accounts for 2 zeros, so we can actually write it twice. So you don't have to, but I would just because it's easier. So because we know it's a 0, then that means we can divide out by that 0 right there. So we have 1, then the 4th, then the 3rd, then the 2nd. Hey, look, you're missing a term. Don't forget the 0. And then the minus 36 on the end there, okay? Bring the 1 down, so you're left with 1. -2 times 1 is -2. 3 minus 2 is 1. Minus 2 is 7. Make sure I'm on the right track here. And then -2 times 7 is -14. 23 minus 14 is 9. -2 times 9 is -18. 0 minus 18 is -18. Plus 36 and 0. Okay, so that means we did it right. Awesome. So we know that x equals -2 is a 0. And show me somehow that you know that that 0 occurs twice. You can either write it twice or you can say that it bounces, but you show me that you understand that that thing is accounted for 2 zeros. Okay. So here we still have a polynomial of, let's see, 0, 1, 2, 3, 4th degree. You still can't factor that. Okay, so let's do it again. And because I know that this is a bounce, you can actually do it twice. Okay, so bring down that 1. -2 times 1 is -2. 1 minus 2 is -1. -2 times -1 is a +2, which gives you 9, making that a -18, which makes that there and that there. So hey, look, that remainder is 0. That means we did it right. That's cool. Okay. So that accounts for this 0 here. So we found those 2. Awesome. Now we've got to figure out the crossing one. Well, this is still a polynomial of degree 3. And I personally really don't want to factor that. You can if you want, but I will still allow you to use your calculator to find that other 0. You don't have to. But if you notice, I went to my table this time and I saw that another 0 happened at +1. So now I'm going to divide out by 1. So bring down the 1, multiply, 0, 0, 9, 9, and 0. Great, so now we have this polynomial. First of all, we know that x equals 1 is a 0. And we have this polynomial x squared plus 9 equals 0. We can now solve that. I would solve by square rooting, so subtract 9. Then you have square root, and now you have x equals plus or minus 3 But then you also have an I because of the negative underneath the square root. So x could be 3i or x could be negative 3i. Okay, so that one bounces. So that's 2. This is the third, this is the fourth, and that's the fifth. And we have one bounce across into imaginary. Okay, this section's really cool because you have multiple opportunities to check to make sure if you're right. So make sure that you take advantage of that. Okay. All right, number 2. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and zeros 5 and 1 plus I. Okay, so we know that if there's a 0 of 5, then that means that x equals 5, and so we also know that x minus 5 equals 0. Okay. Then we also know that another 0 is x plus equals 1 plus I. Well, if you remember from class, the complex conjugate theorem told you that if this was a 0, then this also had to be a 0. Okay? So if we solve for 0 with both of these, we get x minus 1 minus I equals 0, and then we get x minus 1 plus I equals 0. Okay, so now we can make a polynomial out of these. We've got x minus 5 times x minus 1 minus I times x minus 1 plus I equals f of x. Okay, and now we can FOIL. So from class, if you remember, I told you to just leave that first one the same. Okay, and now let's distribute. So we've got x squared minus x plus I times x minus x plus 1 minus I, and then minus ix plus I minus I squared. Okay, now let's simplify before we continue our distribution. X squared doesn't have any friends, so it stays x squared. You've got a minus x, which is a minus 2x, plus ix minus ix. That goes away, so that's nice. We've got a minus I and a plus I, which cancels, so that's nice. And then we've got a 1 minus, well, I squared is negative 1. So minus a negative 1 plus 1 would give you a plus 2. Okay. Now from here you can continue to distribute. So you got x cubed minus 2x squared plus 2x minus 5x squared plus 10x minus 10 equals f of x, and then finish solving, keep it in standard form. X cubed minus 7x squared plus 12x minus 10 is equal to f of x. A lot of work for a little answer, but that's okay. Beautiful. Okay, number 3. We are on to bigger, better things. Okay, determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros for f of x equals that. Okay. Now, if you remember, Descartes' rule of signs told us the number of sign changes in f of x gives you how many positive real zeros that you have. Okay, so given f of x, we have a sign change here, that's 1. We've got a sign change there, that's 2. And we've got a sign change here, that's 3. Okay, so for f of x, you have 3 sign changes, which means that you have 3 or 1 positive zeros. Okay, and the details on that theorem can be found in your notes. Okay, I'm not going to go into it here because that's not what this video is for. But you can have 3 or 1 positive zeros. Now, that also said that if you plug in negative x, okay, so let's just figure out what that is. If you plug in a negative x here, it's raised to an even power, so that term is going to stay the same. Nothing's going to change about that. But if you plug in a negative here, then this whole term becomes negative, and because it's already negative, we can change that to a plus. If you plug in a negative here, the sign keeps itself, so you've got negative 3x to the 4th. You plug in a negative x to that x right there, the sign changes, so you have minus 3x cubed. Plug in a negative x to that x, sign keeps because it's an even power. If you plug in a negative x there, that flips the sign, and then the last one stays the same. So that's f of negative x. And then if we detect the sign changes there, there's 1, 2, and 3 sign changes. So for f of negative x, we also have 3 sign changes. So we have 3 or 1 negative zeros. And again, we don't know if it's 3 or if it's 1, but I'm just telling you it could be 3 or it could be 1. Okay? So now we get to make this awesome table. You've got positive zeros, negative zeros, imaginary zeros, and the total amount of zeros. Okay? Now what you should know from the fundamental theorem of algebra is that the total number of zeros every single time is going to be 6 because you've got a 6 right there as your lead term. So that's something to know right off the bat. Okay? It doesn't matter how many positive, negative, or imaginary, you have 6 total. Okay? So for positive, we could have 3 positive or 1 positive. And for negative, we could have 3 negative or 1 negative. Okay? But if you have 3 positive or 1 positive, you can also pair that. It's kind of like a reasoning through your table here that you can have 3 positive and 3 negative, or you could have 3 positive and 1 negative, right? Because you could have 3 or 1 negative zeros, and you don't know how they pair together. Okay? Or you could have 1 positive and 3 negative. Okay? That can happen as well. So just keep that in mind. So you can have 3 and 3, you can have 3 and 1, you can have 1 and 1, or you can have 1 and 3. Okay? Now what's really nice about this is you know that the total number, regardless of how many specific there have to be 6 of them. So then the difference is just how many imaginaries that you have. Okay? So you've got 3, 3, so that means that you have 0 imaginary. A positive and a negative, so that's 2 real zeros, so that means 4 of them have to be imaginary. You've got 3 and 1, that totals 4, so 2 have to be imaginary. And 1 and 3, that totals 4, so 2 have to be imaginary there. Okay? And what I'm looking for basically is this table. If you just show me that table, I'm cool with that. Okay? Awesome. One more, then you're free. A tachometer measures the speed in revolutions per minute, or RPMs, at which an engine shaft rotates. For a certain boat, the speed x in hundreds of RPMs of the engine shaft and the speed s in miles per hour of the boat are modeled by s of x equals that. And then what is the tachometer reading when the boat travels 25 miles per hour? Okay, so we were given the speed, so let's plug that in. 25 miles an hour is equal to 0.00547x cubed minus 0.225x squared plus 3.62x minus 11. Okay, subtract 25, so you're left with 0 equals 0.00547x cubed minus 0.225x squared plus 3.62x minus 36, okay? Now go to your calculator. Don't even try to factor that. Don't try to find the 0 and do synthetic division. Don't even try it. It's too difficult, okay? Plug that in, okay? And you will see that there's only one positive real 0 that you're interested in. And if you plug it in and find that 0 on the calculator, I'm just going to tell you that is x equals 25.25, but you're not done. You can't circle that yet because it says x is in hundreds of RPMs, so you need to multiply that by 100. And then that means that this boat, when it's traveling 25 miles per hour, is getting 2,525 revolutions per minute. That's a whole lot. That's why boats go so fast. Vroom, vroom. All right, I'm done torturing you. Hopefully that helps. If not, come see me and we can work through some stuff. Make good choices.